Welcome to a short introduction to the SyncMeter framework. SyncMeter is a web-based near real-time collaborative modeling framework. It allows the generation of near real-time collaborative modeling editors for arbitrary graph-based modeling languages. The framework is based on a metamodeling approach. On the metamodeling layer, the concepts of the modeling language an editor should be generated for and their appearance are defined by a visual metamodel. For the graph-based modeling language specified on the metamodeling layer, a new instance of the generic editor component is generated, which allows the modeling with regard to the defined modeling language on the modeling layer. SyncMeter allows near real-time collaboration on the modeling layer as well as on the metamodeling layer. Thus, multiple users at different locations can work together on the same model, respectively metamodel, while changes of remote users become directly visible to the local user. Let's first have a look at a sample instance of the generic modeling editor, as in this case it has been generated for the iStar modeling language. The widget-based user interface of the editor offers two different views of the model. The graph view, consisting of the canvas and the palette, visually represents the model as a graph and allows the addition, rearrangement and removal of nodes and edges. The addition of new nodes and edges is not only possible using the palette, but also using the right-click menu, which, in case of the creation of a new edge, just suggests edges valid with regard to the underlying metamodel. The property view allows the modification of the attributes of the model's objects and relationships. As the editor is near real-time collaborative, modifications of the model are directly propagated to the remote users. To support the users during the near real-time collaborative modeling process, the editor comprises awareness functionality. Objects modified by a remote user are highlighted in a user-specific color. In addition, all operations altering the model are listed in an activity list. To generate an editor for a graph-based modeling language, the generator component is used. Let's have a look at the metamodel of the iStar modeling language, the corresponding editor instance we have been working with before. The modeling language an editor should be generated for is defined in a visual manner using a graph-based modeling language oriented at the one of UML class diagrams. Thereby, each object and relationship of the modeling language to define is represented by a node of the corresponding type. Possible source and target objects for a relationship are specified by linking the corresponding relationship node to the individual object nodes. The appearance of the nodes and edges is defined by shape nodes, links to the objects and relationships whose appearance they define. The shapes can be selected out of a set of predefined shapes or specified by custom HTML and SVG markup. The final generation of an editor instance is invoked using a special generation widget. The generator component comprises the same near real-time collaboration and awareness functionality as the generic editor instance seen before. This concludes the introduction to the SyncMeter framework. Thanks for watching.